All right, in this lesson, I'm going to teach you guys how to solve a trig equation that does not involve the unit circle because the angles involved are not special angles. So remember, special angles are 0, 30, 60, 45, 90, 180, 270, and so on. Any angle on the unit circle is considered special. And sometimes when you solve an equation, it doesn't actually involve a special angle. So what do you do in this case? You have to use what we call a reference angle and the cast rule. So we use these in combination along with your calculator to find out the possible solutions. So let's look at our first example here. It says solve the equation 3 cos theta minus 1 is equal to 0 to the nearest tenth of a degree between 0 and 360 degrees. So be very mindful of the domain that we're working with here and also the units. So we're working with degrees. So first thing I would do is actually write out the equation first. And whenever I solve a trig equation, I always try to solve for the actual trig ratio first. So in this case, it's cos theta. To isolate cos theta, I get 3 cos theta is equal to positive 1. Therefore, cos theta is equal to 1 over 3. So remember, if you try to use a unit circle here, you're looking for all angles on the unit circle where the x-coordinate is 1/3. Now, if you check on the unit circle, you're not going to find any angles with that property, so you have to use a different method. So you're going to use the combination of a calculator and the idea of the cast rule. So just to review here, a cast rule, it tells you which ratios are positive. You may refer to it as cast rule or maybe as add sugar to coffee. Now, if you take a look at our equation here, my cos theta is actually positive. So we have two possible solutions here. We have one possible solution in quadrant 1 and another possible solution in quadrant 4. Both these angles are solutions. So our first solution is from here, from the x-axis to that terminal arm. That's my first solution I need to find. And the second solution is from the x-axis to the next terminal arm, which is our second solution. To find both these values, we need to find what we call a reference angle. And remember, a reference angle is the angle between the x-axis and the terminal arm. And what's really special about theta 1 and theta 2 is they have the same reference angle. So let's go ahead and find that reference angle. To find that reference angle, we're actually going to go back to the equation. So to find reference angle, I have to take the cos inverse of the positive trig ratio. Now it's already positive in the question, but if it was a negative, you'd actually have to take the absolute value and make it positive because reference angles are always positive. So let's see what angle we get when we take the cos inverse of 1 over 3. Make sure you're in the right mode. We should be in degree mode here, which I am. So we'll go second cos inverse 1 over 3, and we should generate an angle here. So the nearest tenth, we have 70.5 degrees. Remember, we can't assume that's our solution yet. We need to go back to our diagram. Remember, 70.5 represents the reference angle. So this angle right here is 70.5 degrees, and the angle for the second solution, that reference angle is also 70.5 degrees. So looking at my diagram here, the value for theta 1 is actually the same exact quantity as the reference angle. So from the x-axis to that terminal arm, that is also 70.5 degrees. So there's my first solution. The second solution went from the positive x-axis to all the way around in the fourth quadrant. To find that rotation angle, we have to take 360 degrees and subtract the reference angle, so 70.5. Okay, so let's see what value we get when we subtract 360 minus 70.5, sorry about that. And let's see what second answer we get here. So 360 minus second minus sign or negative sign, you should get the answer there, 289.5 degrees. So that's my second and last solution. Okay, so within the domain of 0 to 360, I have two solutions, one in the first quadrant, which was 70.5, and one in the fourth quadrant, which was 289.5 degrees. And that is it for that lesson.